Okay, we have a three-part problem here with finding zeros. So the first part of our problem, we are asked to list all of the rational roots according to the rational zero theorem. So to find the roots according to that theorem, what we want to first do is we want to find P and Q. So P is going to be your constant, and Q is going to be the coefficient of your leading degree here. So Q is 1 and P is 9. So to do our rational zero theorem, we're going to do the factors of P over the factors of Q. So factors of P over the factors of Q. And when we say our factors, we say, okay, what multiplies to that number? So the things that multiply to 9 are going to be positive and negative 1, positive and negative 3, and positive and negative 9. And then the things that multiply to Q are just 1, so 1 times 1. So the possible zeros are going to be 1, negative 1, 3, negative 3, and 9. Negative 9, they're all over a 1, so it's just these values here. If we had, say, a 2 over that, we would put the 1 over a 2, a 3 over a 2, and a 9 over 2, etc. So that's the first part. The second part is to, let's see here, find a root of the equation. So we want to see which one of these works. You can test each of these using synthetic division, or you can do a really easier method here, which we're going to go to a graphing calculator to do this. So I'm just going to back this up here a little bit so I can reach my keyboard. And let's see here, come over here and we say Desmos. Okay, that's our graphing calculator we're going to use, and we're going to put this equation in. So we're going to have x to the fourth, so x to the fourth, and then we'll go out of that, minus 2x cubed, so 2x to the third, and then minus 10x squared, and then plus 18x, and plus 9. Okay, so here is our equation, and it looks like we have some roots here. So we have a negative 3, a negative 0.414, so that's going to be probably a radical, and then we have the 2.414, so again a radical, and then a positive 3. So it looks like negative 3 and positive 3 work as roots. So we're going to use those. We're going to go back to our equation here, and we're going to use synthetic division for this. So I'm going to erase this part here, and we're going to synthetically divide out either a 3 or a negative 3, and it doesn't matter which one we use. So let's start with, we'll go with the negative 3. Okay, so we divide out a negative 3, we're going to use synthetic division, so we have a 1, a negative 2, negative 10, an 18, and a 9, and we will bring down the 1. We'll do 1 times negative 3, get negative 3. Negative 2 minus 3 will give us a negative 5. Negative 5 times negative 3 will give us a positive 15. Negative 10 plus 15 gives us 5. 5 times negative 3 gives us a negative 15. 18 minus 15 gives us 3. And then 3 times negative 3 will give us a negative 9. So that will be a 0 there. So we have synthetically divided out one of our zeros, which is a negative 3. And we've reduced this now to a third degree polynomial. So we have an x cubed minus a 5x squared plus 5x plus 3. Since we already know that positive 3 is another 0 of this, because again, we got that from our graph. So if we go to our graph, here we have that positive 3. We're just going to go ahead and synthetically divide again. Okay, so this time we're going to do a positive 3. Okay, so we have a positive 3, and now instead of doing from the regular, the first equation, we're going to go from the reduced equation. So we get our coefficients, 1, negative 5, 5, and 3, and then we synthetically divide this out. And we're going to keep doing this until we get a quadratic. So we have 1 times 3 gives us 3, negative 5 plus 3 gives us a negative 2, negative 2 times 3, negative 6, 5 minus 6, negative 1, and then negative 1 times 3, negative 3, and we get a 0. Okay, so this reduces from a third degree polynomial to a second degree polynomial. So we have 1x squared minus 2x minus 1, which means now I have a quadratic. So now I can solve. So it looks like I cannot factor this, so I want to use the quadratic formula here. And I don't have room there, so I'm going to put it over to the side. So quadratic formula, remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to take that and we are going to go ahead and do this calculation. So our b is going to be negative 2, so we have negative 2, which makes a positive 2. Then we have plus or minus the square root here of negative 2 squared minus 4 times a times c, so times 1 times negative 1. And then that's going to be over 2a, so 2 times 1. And then we'll simplify inside this radical here, so negative 2 squared gives us a positive 4, and negative 4 times 1 times negative 1, a positive 4 again. So we have 4 plus 4 there, which is 8. So this is going to come down as 2 plus or minus the square root of 8 over 2. And then we're going to want to simplify this radical here. So square root of 8, we can pull in square root of 4 times square root of 2, and the square root of 4 simplifies just to a 2. So this gives us 2 plus or minus 2 radical 2 over 2, in which case now we can reduce these 2's, not the one in the radical, so that will give you a 1 plus or minus 1 radical 2, or just radical 2. Okay, so we found our zeros. We have a negative 3, we have a positive 3, and then we have 1 plus or minus radical 2. So we would enter that just negative 3, comma, 3, comma, 1 plus radical 2, comma, 1 minus radical 2. And we found the zeros of the function.